Hello friends, welcome to my home. On the last video, we used a method called sampling to approximate some quality about an object or situation using something we can measure. So the two examples I used were measuring velocity or speed and using that to approximate the distance traveled by an object, or measuring lengths at particular intervals and using that to approximate an area. Now, if you noticed, with few exceptions, the approximations were not very good. So today we're going to introduce a technique to maybe get a better approximations. So this is our example from last video, just displayed graphically. And so if we draw out the left sum, we'll notice, and I kind of gave it away at the top, so left sum, we find all the areas of these rectangles. It ended at 8. The left sum ignores this last point. It's completely not used in the process of finding the left sum. And then if we do the right sum, going from the right, drawing these rectangles, the right sum completely ignores the first point. It's not at all used. So the question might be, what can we do about that? And the answer is pretty straightforward. What if we just went like that? We found the area underneath all of those, right? This is called the trapezoidal rule because on the graph, we connect the endpoints with a straight line, and those make trapezoids. What we do mathematically is we average the left and the right value multiplied by the interval. You might be thinking, how does that go with the other one? Well, if we have the left value and the right value, so let's have the left value be L, right value R, averaging, let's add them, divide by 2. And then you multiply by an interval, which we can say, maybe call it delta x. I don't know, change in x. And if you don't remember the formula for area of a trapezoid, if a trapezoid has, and usually, and one of the things that trips people up, trapezoids are usually drawn this way, where you have one base and a second base, and then a height. The area of a trapezoid is, of course, base 1 plus base 2 over 2 times the height, which superficially looks pretty much exactly the same as this. And that's why, you can do the trapezoidal rule mathematically without ever drawing a trapezoid. But on the graph, looks like trapezoid. So let's do it. Find a distance now by trapezoidal rules. So with these, again, we want to find the intervals 1, 2, 2, and 3. Now we have this extra problem of, well, let's actually average these. So we'd have to do 40 plus 30 over 2, multiply that by 1. And then we'd have to do 30 plus 60 over 2 times 2. And then 60 plus 45 over 2 times 2. And then 45 plus 35 over 2 times 3. 70 over 2 is 35. 90 over 2, 45 times 2 is 90. This becomes 105. And then we have 45 plus 35, that's going to be 80, divided by 2 is 40. 40 times 3 is 120. Then you can add all these up. So we have 140, 230, Hooray! Which I believe from the last video, one side was 355, the other side was 345, so hey, that's convenient, somewhere in the middle. Not just somewhere in the middle, the exact average of the two. All right, let's look at this. Again, the example from last time. But now we're going to, approximate with the trapezoidal rule. So this is 2, 1, 2, 3, and then 2. So we have 5 plus 3 over 2 times 2, and then we have 3 plus 2 over 2 times 1, and then we have 2 plus negative 1 over 2 times 2. Let's negative 1 plus negative 3 over 2 times 3, and then negative 3 plus negative 4 over 2 times 2. Do all this and add up 8. This becomes 2.5. This becomes 1. Let's see, negative 4 over 2, negative 2 times 3, negative 6, and that's negative 7. You add all these up, and then we have, let's see, 1.5. Hooray, which was, again, pretty in between the last two. We'll do this estimating the area. One thing I've been hinting at, and we can go back and check it, is that because it's the sum of averages, the sum of averages ends up being the average of the sum. So one of the shortcuts on the trapezoidal rule is if you've already done the work, if we want to use the trapezoidal on this, we already did the work in the last video finding the left sum, which was 5,200 in this case. And we already found the right sum, which was 5,170. The trapezoidal rule is just the average of the left sum and the right sum, always and forever. So it's 5,200 plus 5,170 over 2, which would give 7, 3. Which is kind of hard for me to do in my head, but you know how that goes. Yeah. This is meter squared, was the unit. So there you have it, a much better way of doing things, the trapezoidal rule. Join us next time when we talk about an even better way of doing things.